As we've already heard, last March the CTBTO monitoring system was put through a comprehensive stress test, which exercised many components of the monitoring system. In the next hour or so, we'll have a chance to learn more about what the stations of the International Monitoring System recorded from the Tohoku earthquake and its aftermath, including the tsunami and the nuclear accident at Fukushima. We will also learn more about the data analysis done here at the IDC in Vienna and how those data and products were made available to our state signatories and other international organizations. We'll also hear of several important improvements that have been made or proposed over the last year. We're fortunate to be able to hear from a number of different speakers, beginning with a discussion on the seismic data analysis done after the Tohoku earthquake, and we'll learn more about the aftershocks generated by this massive event, and also how this routine work fits into the work that's always being done by CTBTO. Next, we will hear about a newly launched effort to improve our ability to locate earthquakes and explosions, which includes working with people throughout the world to have an improved understanding of regional variations of seismic travel times. Next, we will hear and see some very interesting observations from the Tohoku earthquake that were made by our hydroacoustic network of stations, which are the stations that are located in the world's oceans. The next presentation will cover infrasound, which are the waves that propagate through the atmosphere after certain types of events. This is a technology that was developed in the 1950s during the time of atmospheric nuclear testing, and then went into something like a dark age. Recently, with the advent of CTBTO, it's currently enjoying a renaissance and is also being used for civil and scientific applications, such as volcano monitoring and hurricane tracking. The next presentation will talk about the performance of the IMS radionuclide network in spring last year, in which radionuclide stations observed the effect of the Fukushima accident. Then we will conclude the presentation with a discussion of the radionuclide analysis results, how those results were presented to authorized users, and how we use atmospheric transport modeling to better understand what we observed at the radionuclide stations, and how access is provided to the data and products. This can be considered as a refresher for those who may not access the data and products regularly. This map shows the status of the IMS network in spring of last year, and each of the different colored dots represents a different technology at each of the sites. The primary seismic stations are blue, the auxiliary seismic stations are green, and the hydroacoustic stations are yellow. The infrasound stations are the purple symbols, while the radionuclide stations are shown in orange. We can see from this map that this is truly a global network, and it includes stations in some very remote places, including the Arctic and Antarctic regions. It's important to know that each station is connected to Vienna through a global communication infrastructure, which provides a reliable means to send data from each of the stations to Vienna. Thank you.